Hi everyone, I wanted to make this video just to really emphasize the big ideas that I needed you to take away from the task 4.1. So the task was spread out over a couple of days and we had some Ready Set Go stuff thrown in, so I figured I would make this video to kind of just help you understand exactly what it is I need you to know for your quiz for tomorrow. And this doesn't have everything, but this has the really big stuff that I needed you to make sure you understand before taking this quiz tomorrow. So we talked a lot about the difference between expressions and equations. So expressions are the ones that do not have an equal sign. Expressions could be something simple like 2x minus 3, or they could be something very complicated like 1/2 times the quantity x plus 5 minus 6x. Both of those things are considered expressions. They do not have an equal sign. Now, when we have an expression, we simplify it. If we can, anyway. So this first one that I wrote, we can't simplify it. This one, however, there's a couple of different things we could do in there to help simplify it and just kind of make it smaller, right? Before we move on to strategies for simplifying, I want to talk about what an equation is then. So equations are the ones that do have an equal sign. When we have equations, we solve them. So these are really the two big ideas that we're focused on here. Expressions do not have an equal sign. And the thing that we do to expressions is we simplify them. You can never solve an expression. That's not something that you can mathematically do. You can simplify it though. Then we have equations. So equations do have an equal sign. And if you think about it, the word equal is almost inside of the word equation anyway. So they do have an equal sign. That's what's important there. And when we have an equation, we usually try to solve it. All right. Now there's one really important note that we have to talk about here. When we look at an equation, actually, it's made up of expressions. So this big note that I want you to make sure you write down is that each side of an equation is an expression. So these two words are definitely related to each other. We can't have equations if we don't have expressions to build the equations. Okay, but they are not the same thing. Expression is just 1/2 of an equation. Once we put an equal sign in between two expressions, then we actually have an equation. All right, and again, the difference is expressions we simplify, equations we solve. Okay? All right, let's focus in a little bit more on simplifying expressions. So this is something we've been doing, I think since Module 2, we've been working with simplifying expressions. But something really important that I want you to remember is when simplifying, we do not use inverse operations. That is only reserved for when we're solving equations, because an inverse operation allows us to move things to the other side of an equal sign. If we don't have an equal sign, we can't use inverse operations. We do, however, have 3 different strategies that we can try when we're looking at simplifying expressions. So instead of using inverse operations, we've got 3 other things to try. We could try to distribute. And we know that if we see parentheses with a number outside, that's when we can distribute. We could combine like terms. And then the last thing, one of the new things that we introduced to you in section 4.1 was trying to divide first. So we could distribute, we could combine like terms, or we could divide. So let's actually look at these couple examples that we have here. So this first one here says 12x minus 60 all over 3. Well, if I kind of think through the 3 strategies that I could try, distributing usually means that I have to try and that I need parentheses, excuse me. I don't see any parentheses here, so I can't distribute. Combining like terms means I need to take like terms and put them together. Well, I don't really see any like terms. Divide, I do see a fraction. So when we try to use this strategy, the thing we have to remember is we're going to take the top of our fraction. So in this case, we've got 12x, and then it's minus 60. And we're literally taking the top of the fraction and we're spreading it out. And we're going to make two separate fractions. The denominator, or the bottom of our fraction, is going to be the same on both of them. It's going to be 3. So that's kind of the strategy I use. I take the top and I separate it out, and then I just make the bottom the same on both of them. Really what we're doing is we're taking the 12x over 3, that's what we wrote right here, and then we're doing minus 60 over 3. That's what we're doing right here. Now we need to actually try to simplify this. That's where the dividing part actually comes in. All we did at first was split the fractions. So we're going to do 12 over 3 and tell our calculator to simplify it. So we get 4x minus, now we're going to do 60 divided by 3. And we get 20. So this expression here simplifies down to 4x minus 20. Now let's try the second one. Again, we kind of have to remember these are the only three options: distribute, combine like terms, or divide. So when we look at this one, we can see there's a number, so it's 5 minus 3 times the quantity of x plus 2. These parentheses here tell me that I'm going to need to distribute first. So I'm going to take this negative 3 and distribute it inside the parentheses. And remember, when we distribute, we're actually multiplying. Since I'm not doing anything to the 5, it's just going to come down. It's just going to chill. But we're going to do negative 3 times x and get negative 3x. And then we're going to do negative 3 times positive 2, and we get negative 6. So now I was able to get rid of the parentheses by distributing that negative 3 inside. By doing that, I also created some like terms now. So now I can see that there's a 5 and a negative 6. Those are both like terms because they're both just constants. They're both just numbers. When we combine like terms, we add them. So in our calculator, we're going to do 5 plus negative 6, and we get negative 1. That means our answer here is going to be negative 3x minus 1. The negative 3x didn't have any like terms, so it's just going to come on straight down. And this is our simplified expression. Remember, on both of these examples, I was simplifying, so I did not use inverse operations. I didn't do the opposite of anything. I really just did what was there. Okay? Now, let's take a look at the solving equations. So, this special note real quick that I want to point out is that sometimes when we're solving an equation, we may have to simplify one or both sides of the equation first. So we may have to do exactly what we did over here before we can even solve the equation. Once we've simplified both sides, if we can, then when we solve, we use inverse operations. Again, those inverse operations are what allow us to move on either side of the equal sign. So let's take a look at this first example. We're supposed to solve, and we can tell we're supposed to solve because there's an equal sign, which means we have an equation here. Now I see variables on both sides, so what that means is I need to get them together. I always like to move my variables to the left side, but that's just me. If I want to move this 2x over to the left side, that's where I'm going to need to use inverse operations. Since this is a positive 2x, I'm going to subtract 2x from both sides of my equation, because that is what will get this one to cancel out. 3x minus 2x is just 1x, and then the minus 5 comes down, and so does the 18, because I didn't do anything to either of those. Then when I look, I have x minus 5 equals 18. In order to get rid of this negative 5, I'm going to use the inverse operation. So that means I'm going to add 5 to both sides. So now I get x is equal to 18 plus 5, which is going to give me 23. So my answer here is x equals 23. Then let's take a look at this second one. This is where that special note kind of comes into play. So remember, sometimes we might have to simplify first. When we look here, we see parentheses, just like we did over in this example where we were simplifying. So sometimes we can actually divide first, but if we look, there's two terms over here, and trying to divide by this 2 first is going to make it really messy. So instead, we're going to simplify this expression on the left side by distributing. So we're going to do 2 times x to get 2x, and we're going to do 2 times negative 3 to get negative 6, and then we're going to bring down this other side, this 5x plus 6. Now when I look, both of these sides are fully simplified, which means now if I could just get the variables on one side and the numbers on the other, I'd be able to actually solve my equation. So now it's a lot like this one. Again, I always like to move my variables to the left. So to move this 5x, I'm going to subtract 5x from both sides. 2x minus 5, well, if I'm not sure, I can use my calculator. So 2 minus 5 is going to give me negative 3. That means I have negative 3x minus 6 equals positive 6. My next step is going to have to be to get rid of this negative 6 to get it away from the x. Since I moved my variables to the left, the numbers have to go to the right. So in order to get rid of this minus 6, I use the inverse operation, which means I'm going to have to add 6 to both sides. And I'm left with negative 3x equals 6 plus 6, which is 12. And then my very last step is going to be to divide by negative 3, because division is the inverse of multiplication. So I get x is equal to negative 4. So that's the big idea that we really needed you to get from these last couple of days. Expressions don't have an equal sign. We simplify them using these 3 strategies. Equations have an equal sign. And even though we sometimes have to simplify one side first, in order to truly solve, we have to use inverse operations. Okay, there's one more thing I want to talk about before you guys get started on your practice. This was another big idea from the last few days, being able to justify our answers here. So 2 students are trying to solve this equation, 3x minus 8 equals 26. Student 1 thinks the first step should be to add 8 on both sides of the equation. Student 2 thinks that the first step should be to divide 3 on both sides of the equation. Which student's first step would lead to a correct solution? So if I think about this equation, 3x minus 8 equals 26. If we think back to the beginning of task 4.1, we were actually building these equations. So I want to take a step away from all these words that are here, and I want to think about if I were building this equation, what order would I do the steps? Well, I would have to do x times 3 first, and then I would subtract 8. Which means the first thing I'm going to have to do in order to solve this equation would be to add 8. I can't divide by 3 first, because when I was building the equation, I subtracted 8 last. And we know that when we're solving, we have to undo the operations in the reverse order. So if we look, we know we're going to add 8 first. That means student 1 is correct. And our justification here is pretty much going to say what we were just talking through. When we built the equation, so when building the equation, the last step was subtracting 8. So to solve it, to solve the equation, we use the inverse, which is adding 8. So I want you guys to make sure you talk about when we built the equation, the last step was whatever. And so to solve it, we use the inverse, and then tell me what the actual inverse is. All right, so you guys are going to work on your review for your quiz, and make sure that you check your answers. They'll be posted on Google Classroom. And then if you guys have any questions, please send me an email and I will do my best to be able to give you a hand. All right. Good luck, and I will see you all later. Thanks for watching.